Welcome everyone to our second webinar in our energy series. And we've got Gabriel Hakim here today to talk to us about energy efficiency. So I'm quite excited about today. Gabriel is well known in the dairy industry and in the energy industries. Gabriel's been involved in the dairy industry for over 30 years and has worked with farmers and service providers in areas of mastitis control, milk quality, dairy hygiene, refrigeration, milk machine performance, and their interrelationships. So from that, Gabriel transitioned then into the energy space. So for the last 15 years, Gabriel has been focusing on energy efficiency and sustainable energy technologies and how they can be best utilised in the dairy industry. So he's got a passion about helping businesses to become commercially clever about their energy. So it's going to be fantastic to get Gabriel to share those insights with us today. So today Gabriel's going to be talking about energy use on dairy farms and energy efficiency opportunities for dairy farms.
Thanks very much for inviting me today. I can see from the registrations that we've got people today from a whole range of different backgrounds, so I hope that the information that we provide is actually applicable to your situation and your perspective. To keep within the time frame that we have, I've narrowed the scope to energy used at the dairy only. I acknowledge that there are some, or particularly the irrigation dairy farms, where energy use of the dairy comes a very distant second. But for today, I just want to focus on the energy at the dairy. And why there's such a focus for energy at the dairy is because farmers particularly have been telling me that the energy costs and the cost of energy at the dairies been a significant factor and a significant focus for their attention to try and manage costs. As you can see, over the last 10 or 15 years, the cost of power has really gone up. But fortunately, in the last few months, we're starting to see prices come down. The other reasons I've been told is, or farmers expressed to me, is that they're really uncertain about the information they're getting around energy use. They're concerned about power shortages, power outages. They want to try and become more secure. There's also community pressures in terms of people wanting us to move more and more to renewables. So there's a whole lot of pressures, there's a whole lot of concerns, and it's often very difficult to find or navigate this new energy landscape. So the other thing is that when you do want to make a move, often the investment required is quite prohibitive, and so it really poses quite a few challenges in trying to make a transition. So what's happened in terms of what farmers have been doing? Well, I would say the major response by dairy farmers has been to install PV. And we see systems from 5 kilowatts to 100 kilowatts going on dairies. And I won't talk about that further along, but that's been one reaction. Another reaction or response has been, particularly 5 or 6 years ago, a lot of farmers started to try and reduce their costs and reduce the energy use by sort of taking shortcuts, and that involved things like reducing the temperature of their hot water in terms of adjusting their thermostats. Some farms started skipping wash cycles. So, for example, in the PM wash, they would not do a final hot rinse purely to try and save money. I also noticed that scheduling and servicing was being stretched out, which had its own challenges and consequences. Some farmers actually changed or did a bit of negotiating, and I found a bit of retail because, as you can recall, especially in the last 5 or 6 years, there was, you go one retail and they offer you a 35% discount or 40% discount. And so there was a lot of discounting, a lot of confusion as well as people tried to find a better price. The thing about all these strategies was just trying to save on costs, but it's sort of like a vicious cycle because you can make some savings, certainly some people make some huge savings, but in the end it's frustrating because almost like chasing a tail because it's really just a pricing mechanism. What we're really interested in trying to see how we can improve the situation by tackling how much energy is used and how well it's being used, and that's what I want to focus on today. So where is energy used at the dairy? Well, what I've done here is I've actually presented some information regarding the results of energy audits that I've been doing over the last 10 or 15 years. Here's a sample of about just over 200 dairy farms that we audited. And what I've done here, what this shows is I've broken up the energy use of the dairy into 7 categories: milk harvesting, cooling, water heating, cleaning, pumping and feeding and so forth. And there's 2 dairy types here. The yellow one is the conventional milking system dairy, and then the darker one is dairy that are, the robotic dairies. Because we've done, I think, I ordered about 16 or 18 automatic dairies. What you find typically, and it's interesting that even over the last 10 years, the energy mix or the energy use mix hasn't changed much on a dairy farm. We still find that milk cooling, water heating, and milk harvesting are the predominant users of energy. And depending on the farm, even though it's small farm or big farm, milk cooling is still around 30%, water heating is around 30%, and milk harvesting is around 18 to 20%. And in milk harvesting, the biggest energy user, of course, is the vacuum pump, which is usually around 16 to 18% of the total energy use at the dairy. Water heating is around 30%, as I said, but these are general, these are the figures represented by the survey. But what's really important is that you need to find out what's happening on your farm, and the best way to do that is through an energy audit. And one that focuses on all these key elements. But the energy audit is only one component is about finding where the energy is used, but the real essence or the real insight is working out how well the energy is being used. So, for example, with milk cooling, how efficient is your milk cooling system, or how efficient is your hot water heating system. So if you do get an energy audit, don't just look at the breakup because it's interesting. The challenge is to really delve in and see how well that energy is being used. So you get your energy audit, you do a bit of assessment, you look at your energy use and how you compare. Well, one way of comparing is looking at a thing that we call is energy intensity, which is basically how many kilowatts you use per 1,000 litres of milk. Or we can look at a costing way, which is dollars per 1,000 litres of milk. The easiest comparison is using the kilowatts per 1,000 litres of milk, and the average that we found over probably 500 audits is about 50 kilowatts per 1,000 litres of milk. Now, this number has been bandied around the industry as an indicator of efficiency. I think it's really just, as the word implies, it's an average. I mean, you can go to some dairy farms and do very little power because they're very frugal and they can actually get a low intensity. It doesn't mean that the energy that they actually use is efficient. So you've got to really be careful on how you interpret these numbers. So if you're going to tackle how much and how well, I've worked out the 3 steps that we need to do. And these are the 3 steps that are involved to do with 1, using less energy, 2, is increasing the efficiency, and then the 3rd step is how do you then source the cheapest energy. So let's look at the first one here. What do we mean by use less energy? Well, there's 2 components here. One is about reducing waste, and the other one's about reducing demand. And these are really obvious things. These should be the first thing that you tackle. So it's stuff like turning off stuff that is not used. Now here's a very small example. This is a dairy farm in Tassie. Now when I did the audit there, I noticed this light here, this little inconspicuous light, which they told me was on all year or most of the year. Now, it only needed to be on for a small period of time. So by doing that, even though it was not a big number, it was nearly $300 worth of savings just by one light. Having cooling systems that are well insulated is another way of stopping the heat gain and therefore extra cooling. This tank was outside, and you can imagine what happens during summer. This tank here below, the ambient temperature outside was 18 degrees, but when we measured the surface temperature of that tank, it was 45 degrees. And you could feel the heat coming through into the inside of the tank. So you can imagine the impact that has on cooling. So this is all about working out ways to reduce what you're using and also to to get rid of waste. The second step's about increasing energy efficiency. Now, the way we can do it is simply how we do the things around the dairy in a better way. So energy efficiency is all about achieving the same outcome using less power or Another term that gets used is called energy productivity, which is about using the same amount of energy but actually getting a better outcome. I'll give you some examples shortly. So how do we actually become more efficient? And here are some simple things that we often overlook. For example, here's a small refrigeration unit, which is a small little goat dairy. Now, this condenser here was inside. There's a whole lot of equipment around there. It could barely work because there was the air circulating was the hot air. That was incorrectly located. Here's an air compressor. Now on robotic dairies, air compressors are a significant power user. Here's one with a block filter, and so therefore it was running probably 20 or 30% more than what it needed to. Here we've got icing, which is on the back of the vat, which indicates that the system is poorly serviced. Therefore, we're using a lot more energy, or we're wasting a lot more energy to try and cool that milk. The third step is about increasing the energy, about how you get the cheapest source of energy. Often that's renewables. As we know now, renewable energy is the cheapest source of energy. So the response has been people put on solar PV, but it's not really a fix. I mean, solar PV is a good source of cheap energy, but what happens? Let's look at a typical dairy farm. Here's what this graph shows you the power useful during the day. So here, if we start around 10:30, 11 o'clock at night, what happens? The water or the hot water service turns on and starts heating water. That continues to about 1:30ish, and then it's probably up to temperature, but this bit between about 1:30, 2 o'clock to about 4 o'clock is just maintaining that temperature. Then on this particular dairy, milking starts at 4:30, and here we have when all the equipment's being used, and then the same thing in the afternoon. In the middle of the day, there's very little power consumption. So this profile causes some issues. Here we've got all the equipment being used here, and therefore we're seeing things like demand charges coming into the dairy industry. So this causes us to have higher demand charges. When we put a PV system on, this is what typically happens. Most of the energy that's generated, obviously, is in the middle of the day. Some dairy farms have got the ability to put panels to face more westerly, and they can capture more of the afternoon sun, and therefore offset some of the energy use in the afternoon. But still, most of it is not utilised, and therefore either gets exported, and therefore you offset the cost of power. So really it's a pricing thing. But as many of you will know or have heard in the media, that there are some challenges now with so many PV systems on supplying power to the grid, that there's a lot of export restrictions going on, and the price that people are receiving for the exported power is reducing. I've heard prices now down to 6 cents per kilowatt. So this really creates a challenge, and that's why PV systems are great, but they're great if you're going to use them strategically. And in this example, you don't get very good use of your PV investment. So if you really want to drive down energy costs and by reducing your energy use and improving efficiency, you got to do these things first. Because if you don't do this, and then you go and try and get your PV system or your cheaper energy source, then you're wallpapering over the energy waste. You're wallpapering over the inefficiencies, and which means you need a bigger or more energy to cover those things, which often results in a much higher or much larger PV system. So so what are some practical things to do? Okay, now believe it or not, in 1994 we wrote a book about cooling milk on dairy farms, and I am sad to tell you that whilst cooling can be really efficient, we still see a lot of dairy farms where the basics of cooling efficiency aren't being undertaken. So often farmers don't have they can't tell whether their plate cooler is working, for example, which makes things hard. So for about $3, you can get a temperature sticker, which is like a fish tank sticker. Put that on the water inside, and then put another one on the milk outside. And when the milk comes out of the plate cooler, check that the coolants and the milk flow in opposite directions. They're the basic things to do. For those of you that got the large industrial plate cooler, the difference between the milk coming out and the water going in should be 2 degrees. So if water's going in at 18 degrees, milk should be coming out at 20 degrees all the time. For those who've farmed with the older style, plate coolers usually a lot smaller, it's a 3-degree difference. So these are, because the thing about plate coolers is it's the cheapest way of cooling milk. Because you're getting water from a bore or getting water from a stream, and that bore water is usually around 16 to 18 degrees, so that means you can get milk into about 20 degrees. But we've seen these things not work very well. Milk goes into about 26 or 27 degrees. Most of the time we found that they're, instead of 2 degrees, instead of 3 degrees, it's more like 6 degrees difference or 7 degrees difference. So for every million litres of milk, if you just did that, you'd save almost $400 a year. So if you're doing 3 million litres of milk a year, just by doing a simple improvement here, you save around $1,200 off your electricity bill. Here's a prime example. We put some stickers on this plate cooler on this dairy in Western Victoria. The expectation was a 2-degree difference between milk coming out and water going in was actually 10 degrees. By improving that, we could reduce the bill by nearly $1,350, and that was back in 2008. 18. I asked the farmer why was this the case, and the problem was that's how it was installed back in 1998. So for 20 years, the plate cool's been working the wrong way. So so you can do the math to see the impact that's had. When it comes to heating water, most dairy farms have got the old hot water services, or Wilson or Edison hot water. They're really, really inefficient. Okay, you might, for every unit of energy that you put in, you're only going to get 1 unit of heating out. The unfortunate thing also, these are very you've got poor insulation, so we've measured up to 20% heat loss. 27% of the energy gone into heating the water is actually lost through inefficient insulation or poor insulation. A lot of farms we need to check the temperature. If you're coming out in the morning and you're seeing steam coming out of the dairy, out of the top, or the heater is boiling, that consumes a whole lot of energy. And in fact, to make water boil, you need almost 550 times more energy than you do from getting it, say, from 85 to 86 degrees. So that's a real problem. So heaters, I see a lot of farms where the thermostat's up to 100. You don't need that. And in fact, if you put water into a milking machine at 85 degrees, inside at 50 kPa, the water will boil and the steam will be generated, cleaning performance will be reduced, and you'll damage the vacuum pump. So, for a typical dairy farm, say uses 1,200 litres of hot water, this unit is costing you around nearly $6,000 a year to heat water. Why would you do it? I mean, that's the way we've done it. There are better ways to do this. For example, commercial heat pumps. Now, I hear once I mention the word heat pump, everyone goes, cringes and says, oh, they don't work, they're hopeless. And because a lot of people had bad experiences with the quantum heat pumps that were installed 6, 7, 8, 9 years ago. And the reason why a lot of those failed was purely because they installed incorrectly, plumbed incorrectly, and they weren't maintained the way they should have been. But if you get a commercial heat pump, for 1 unit of energy, you can get up to about nearly 5 units of heating. So that's a huge difference. Also, the tanks are really well insulated. The heat loss is very small, so you're not wasting heat. So, for the same amount of heating, you're going to use 75% less energy. So, the same 1,200 litres of hot water, and these heat pumps, the new commercial ones will heat to 80 or 90 degrees. So if we had 1,200 litres of hot water a day, we could save nearly $4,500 a year. By installing these systems, the payback's around 7.5 years. And if you get onto the AEIP grant, and you can get 50% towards this, then your payback's less than 4 years. Variable speed drives. Now, I see a lot of farmers wanting to put in VSDs on milk pumps because, and we all know the reasons, really, for $3,500, I can't see the benefit I mean, a lot of these systems cost between 3 and 5 grand to install. I really can't see the benefit. The claims about milk cooling improvements, yes, but really, if you fix the plate cooler, you shouldn't have a problem. If you do want to go down this track, why not consider a butterfly valve with a hole drilled into it as a flow restriction, as a way of restricting the flow? That's for $200, you can achieve the same outcome. For vacuum pumps, it's a very different story. For those farms that have had 2 vacuum pumps, for example, a lot of the old rotaries built in the 90s, or if you look at your test report form and you've got excessive reserve, or your vacuum pump runs for more than 5 hours a day, or if you got a double up dairy with pulsation something, you're a really good candidate for a vacuum pump, VSD on the vacuum pump. Also, blower vacuum pumps, they're ideal for VSDs. Or for those oil ring vacuum pumps, you can also slow down the pump, which might be a cheaper option. So I want to show you an example. This is a farm in the Western Victoria, which has just installed a VSD on a vacuum pump. The vacuum pump was a blower type of vacuum pump. The dairy is a 50-unit rotary with cut removers and milking about nearly 600 cows. The average daily consumption of the vacuum pump was around 49 kilowatt hours a day. The VSD was installed on the 4th of February, and after that, the daily consumption almost or halved. So we worked out that there's a saving there of around 9,000 kilowatts and almost $1,500, and that's a 3.8-year payback before any grants or whatever. So that's a really good example of how these things can work. The other thing is that VSD on this vacuum pump has reduced the demand charges as well. So what do we do about people's solar? For those farms that have got solar, those farms that have want to put solar on, how do you do it? Well, we got to actually change the way we do things there. You got to change your thinking. You got to think, how can we move this sort of load into where the sun shines? So you got to challenge the way you do things. You need to look at the whole dairy because there's more than one bit of equipment. So let's focus on what we can do. First of all, what we don't want to do, there's a real drive to put in huge chillers that are, because people are really keen to get their milk down to 4 degrees by the time it hits about 6 degrees. The problem with this is huge chillers mean huge power requirements, and often the PV system, if you want to try and you can't utilize this because this happens during milking, not in the middle of the day. A different way of doing that is we can load shift. We can actually create a thermal battery. We can use a system which is a third of the size. We can run that during the day using solar, and therefore we can reduce the cost of cooling milk by 30, 40, 50, 60%. With heating water, the old way is really the old way, and it's an inefficient way. 36 kilowatt, these are two 18 kilowatt units. We can do the same job with 6.7 kilowatts. Still get 90 degrees, but the other thing is now because it's only 6.7, we can actually do it here using our solar PV, whereas in this instance we can't really. We can sort of do it, but it doesn't actually do a very good job. The other question I had anymore is, do you really need 90 degrees? We actually don't. So here's a system which is a reuse system that's been going now for 5-6 years. It's low temperature, so it's around 50 degrees only for one of the units. And this uses 1 to 2 kilowatts per day, if that. So it's very, the cost is hugely reduced. I want to just finish up now with the dairy that we and how you bring it all together. So here's a dairy. It's a typical dairy, 40 units. It's a double up. In 2016, it was about 18 years old. It was about 300 cows, and the power consumption, the annual power consumption was 123,000 kilowatt hours. The farmer and I got together and we decided to build we had two options: to build a new rotary following traditional way, which is big hot water services, etc., and with some efficient stuff like VSD on the vacuum pump. But that was typical. But instead, we opted to do a really energy efficient dairy. So we built, so the farm built a 50-unit rotary with every bell and every whistle. We've got milk measuring, we've got cow ID, we've got condition scoring cameras. There's a big office with a lunchroom. There's a computer system. There's everything that opens and shuts. There's security cameras running. There's all sorts of stuff. The interesting thing was that we had we also increased the number of cows on the farm, and milking went down. So, well, after a year, 18 months later, I went back and we did a review. Now, here's the original dairy, 123,000 kilowatt hours. If we built a traditional rotary dairy, we would see that the power use would be around about 164. On this dairy, we've reduced it. We're actually using less than what we did in the old dairy. A good proportion of that is coming from a 45 kilowatt solar system, which we use 80% of the energy that's generated. The outcome's been, well, we've had more cows, more milk, but we've had a dramatic reduction in the bills. We've also reduced the energy intensity of this dairy. And the dairy was completed in October 16. You can just see what happened with the bills in the ensuing months. So I want to wrap up now and say that some of the myths that we encounter, we don't need hot water, we don't need 90 degrees, we don't need these high temperatures to really clean the milking machine effectively. But you just can't turn down the thermostat. You need to have the right wash program to do that. But that's a huge saving. If you go from 90 to 40, you get halve your heating costs. There's no real change in the cleaning costs. You can also then use things like heat pumps and preheaters, and therefore make huge savings there as well. Don't opt for a huge glycol chiller. I've seen chillers now that are around 120 kilowatts because they say that's the only way to cool milk. Well, it's not. We can do things so let me go back here. With this dairy, we opted for the 12 kilowatt chiller. Everyone said we couldn't cool the milk unless we had a 85 kilowatt chiller. We've done the same job using probably 20% of the energy that would have been used with the chiller. So, but make sure that the plate cooler is working. Most people, like I said, are sourcing water from a bore, which is usually around 17, 18 degrees. That's really the cheapest way to cool milk using that external source. So let me just wind up now. So how do you make it work for you? Well, it's obvious. Don't do number 3 first, do number 1. Then do this component before you put your solar on. But also have a way of monitoring what you do. Don't just set and forget. Something we did an audit. We did 28 audits of 29 dairy farm audits in Queensland not long ago, and of the people with solar PV on their roofs, we found that 70% of those solar PV systems weren't working, and the farmers didn't know about it. So you need to monitor, then you need to read, then you need to fine tune, then you need to go again. Here's an example of monitoring system. This is the dairy that we talked about, the rotary dairy, where we constantly monitor stuff to make sure it's working efficiently and effectively. You got to manage your system, and then there's other equipment, and then you can deploy equipment such as solar diverters or systems where you can capture the solar energy and you can divert it to other uses. So there's equipment around to use, but this equipment should be used at this point, which is number 3. You need to do these things first if you really want to make an impact. So finally, I'd just like to wrap it up and just say, look, I encourage all farmers to participate and get involved with the Ag Energy Investment Plan, where you can get some grant funding to do energy efficiency work. It's really, really fantastic because it's 1-for-1. I think you'd be silly not to take it up. There's some additional information on the Dairying for Tomorrow website as well. So Sarah, it's been a bit of a rush. But I think if we can open up for questions, then we'll go from there.
Fantastic. Thank you, Gabrielle. That was absolutely fantastic. I have heard you speak once or twice before, and it has always been fantastic to listen to you speak with just the wealth of knowledge you have there. It's always great. We do have a few questions that are coming through at the moment. We've got one from John that is, would it be possible to use heat from milk to get hot water with a heat pump?
Yeah. Yes. John, this, for example, this farm here, we've got an extra plate cooler, and we're doing this on a new farm where we're using them before the milk goes for the traditional plate cooler. We're capturing some heat off the milk to the plate cooler into this rinse tank, so we're achieving 32 degrees in this tank. But then And so that's one way of capturing heat from the milk. And of course, the other way is to put a heat recovery unit on your refrigeration unit. This really goes well with farms that have got a year-round or split calving pattern because it's dependent on milk flow. But you can achieve, say, 50 or 60 degree water through a heat recovery unit.
Awesome, fantastic. Hopefully that answers your question there, John. We've had a question come through from Helen. She's just wondering, what about any new technologies that are on the horizon that we should be aware of? So is there any new energy technologies on the horizon that we should be aware of that will be suitable for dairy?
Yes, there's some exciting stuff that's sort of on the cusp, but the issue that we have with dairy, or my issue with new, new technology, even though I love it, the reality is we need a robust, no nonsense technology to work on dairy farms. And so, for example, there's we're looking, I'm involved with some people that are looking building refrigeration units that are based on DC power. Use DC motors rather than AC motors. And that's a hugely efficient way of getting energy from, say, a PV system or a wind turbine and directly cool milk because you don't have to go through transformers and DC motors far more efficient. There's other ways, the other ways that we're thinking of, and I'm involved with a few organisations where the new technology is actually not that fancy, but it's really valuable. Where, for example, let me go here. When you have a monitoring system, it captures information. The next step, I reckon, is using that information to make decisions. And this is there's a product out here from Energy Smart Water, for example, which says, hey, look, we've got excess power. The hot water service has been heated. Can we divert power to do another job on the farm? So that's where I think the next opportunity is using that energy from the sun PV system and getting to do jobs that may not be, not based on a timer or a schedule, but it's based on what's really happening. So the hot water doesn't need heating. For example, on the shed here, we've got the chilling unit running during the day. It cools a body of water, which is our thermal storage battery. Now that might finish cooling by, say, 1 o'clock in the afternoon. The sun is still shining. What other job can we do now? Because it's a sunny day. Well, we're actually going to tell them to turn on this other condenser unit, which is used for the first plate cooler. So we're doing other jobs. Or we can turn on the feed mill and actually do some turn on the grain crusher and crush some grain. So the next step for me, I think, is being smart on how you use the energy that you're generating on your farm, because I think most dairy farms that have a PV system may only actually utilise 20 or 30% of the power that they generate, and the rest gets exported or gets limited. So how can we be clever about how we use that?
Fantastic. That's great, Gabrielle. Yeah, definitely with our solar, especially because our highest demand periods in dairy aren't during that middle of the day when we're generating that solar. Yeah, being innovative with how we use that is definitely something we need to be thinking about.
Can I just add here, like the cooling system here on this dairy. This is a 600, 700 cow dairy. The tilla's the tilla's the same size as you put in like a 200 cow dairy, but we're doing the job here. But we're in doing this dairy, we spent 120 or 120 grand more than the traditional dairy. The payback's it's already paid for itself. That's 4 years later, 4-year payback, and now we're in front. It's costing only a couple of dollars a day to cool milk, and in this case we're also heating water as well off the chiller. So heating water is costing only probably about $1 a day, max. So it's about how we're using that power making decisions.
Fantastic. Thank you, Gabriel. We have had a question from John, and he says, you talk about the old Wilson hot waters going to about 90 degrees. Any ways of using heat pumps to reach this temperature?
Yes, yes. There's a couple of brands now which do commercial heat pumps using CO2 as a refrigerant, and they will achieve 90 degrees easily. Okay, so we've got 2 units going. The AEIP program is doing some work at some demonstration sites. We've got one in South Eckland at Sam and Peter Doolan's farm. There's a heat pump going there. We're going to hit 90 degrees water using a heat pump, and that's going to be run predominantly using a solar PV system. So we're going to go, we hope to reduce power consumption by 80% and then reduce the cost of the power by about 90% because we're going to do most of it on PV rather than doing it off peak. So yes, there's a few systems around. If you want to contact me later, I can put you on to the right people.
Awesome, fantastic. We do have a couple more questions, so we'll keep pushing on through those questions if that's okay, Gabby. And I have muted you just due to there was a bit of feedback happening there. So we've had a question from Libby. So what about batteries with solar PV systems?
So Libby, look, batteries are a great idea. I'm a bit biased because I think the cost of providing a battery system for dairy farm use is still not financially viable because you need a lot of battery and it's still quite expensive. Even now I've seen prices down to even $400 a kilowatt. It's still not a viable option. The better way is to think about other types of batteries, which are things like thermal storage. And so rather than doing an electrical battery, we're going to do like a cooling battery or a heat recovery system. They're just not a form of energy storage. I think in the future, 3 or 4 years' time, I think batteries will then become a good option. So if you're thinking about putting a PV system in, the question I'll ask your supplier of the PV system is my inverter battery ready? So when the price point comes, then it can be done. When I looked at this 4 years ago, we looked at batteries for that dairy that I just talked about, the rotary dairy. The battery was going to cost $250,000 to run to put sufficient battery power to run the dairy, say, for a day and a half. So it's not a viable option at the moment, I don't think.
All right, thanks for that, Gabrielle. We have had a question. What's the rough price of an energy assessment for a farm? And what are the general payback periods for different types of investments?
There's 2 types of energy audits. There's a type 1 and a type 2. Type 1 is for want of a better word, a simplified one. Type 2 is more in depth, where you do a lot more analysis. Depending on the size, but type 1 is somewhere around 3.5 to 4 grand. A type 2 can be anywhere from 10 grand to about 16 grand, depending on the complexity. That's why the AEIP program is really good, because you get this paid for. In terms of payback, the certain equipment like the VSDs on vacuum pumps, like heat pumps, like thermal storage chiller systems, I think can vary between 5 and 12 years, somewhere around there. That's before you get any funding. So then that brings, if you can get funding, which is 1-for-1, then that brings the payback from, say, two years to 6 years. As I said at the start, the big challenges for most dairy farms is the cost of change is so prohibitive, because, even to change a hot water service from the old Wilson or Edson type to heat pump, a new heat pump's going to cost you, say, 30 grand. You can go and buy the old system for about 12 grand. But over a 10-year life, you're actually going to be far better ahead with the heat pump. But that initial change is difficult. So this is where I reckon it makes really clever, it's a clever move to use the AIP to help you make that transition. And once you've done that, then the sky's the limit, because then you can use PV to run your hot water system. So, but it's too hard to do with the traditional hot water service, because you need to have preheaters and so forth.
Yeah, thanks for that, Gabriel. We've had a question come through regarding batteries. What's the
Yeah.
dollars per kilowatt hour price that makes it viable for dairy farms to utilize batteries?
I haven't done the latest figures. I thought, now, if I give you a number, you're going to quote me. I did some work on this about 18 months ago, and it's changed. I think there's a figure around 130, 140 per kilowatt. At that stage, batteries were down to about 400. They're still, and they're coming down again. But also, the challenge is the life of the battery. Everyone quotes these long lives of batteries, but I'll look at the economic life, which is probably 7 years rather than 10, 12, 15 years. Some battery suppliers will give you 25-year life on the battery, but look, it's still, I don't know enough about that area to as a general thing, you need to go into specifics, and we can't use things like, we can't make comparisons like the domestic market, which, as you know, with homes using things like Tesla batteries and so forth, because we're on a wholly different scale here. And so the long and short of it is that I reckon around about 100, 150 bucks is starting to come close, but depending on the life of the battery as well.
Thanks for that, Gabriel. And when we're considering the costs for different investments, are we also and the payback periods, are we also considering the stacking of other costs like the savings on demand charges, etc., when we're looking at those paybacks?
No, sometimes we do that, but a lot of the simple paybacks don't often factor in demand charge reductions. What we find is that Well, I reckon I may have seen 1,000 dairy farm bills over the last 6 or 7 years, and I would say probably 80% of dairy farm bills that we see there are no demand charges, but the demand charges are starting to creep in. On those farms, we'll then look at the impact on demand charges. So it's really case specific at the level of detail. And still the demand charges aren't as huge as other industries, but they are growing. So it will become an important factor in the future, I think, to include them in.
Is there an opportunity, or do you also incorporate bioenergy harvest from biowaste into your energy projects?
The short answer is no, but the long answer is yes, we'd like to. Remember, there's a couple of people now that are supplying smaller units and may be suitable for application on dairy farms. But then again, the thing that I really want to stress here that whilst there's all these different options, a dairy farmer's life is always bloody busy. And you don't want to then add more and more tasks and responsibilities onto the dairy farmer's workload. So whilst all these new technologies are fantastic, you got to manage them. And that's why I want to try and keep it simple at the start. We know things like PV and wind work. We can actually track the performance with other systems like bioenergy and all these other things. Fantastic, but then you got to worry about the feedstock. You got to worry about making sure that the output is consistent compared to the load, and because it's doable, but it's time and thinking power that's required to manage it. It's no set and forget. So at this point in time, I would say those other things are great, but not practical for the dairy farm to go into the store tomorrow and incorporate that into their systems.
Fantastic. Thanks for that, Gabriel. And I completely agree. There's a lot more complexities when it does come to anaerobic digestion, and they're definitely not a set and forget system. So the other question and the last question we have here, and they've said, thank you for excellent presentation. Are there any geothermal heat pump applications in dairy farms in Australia so far to assist with water heating / milk cooling processes? Or are there any insights into this being a potential?
Huge potential. We tried to get a geothermal heat pump up and running on a dairy farm down in Yarram. This was 3 or 4 years ago now. The only supply, the issue I have again is if it breaks tomorrow, who's going to fix it? So you need a local person that can support the service. It's all well and good and fancy and saying we got all this new kit, but when it breaks down on Easter Sunday, you want someone that can come. Otherwise, you compromise milk quality. So there's a mob in Gippsland that do geothermal heat pumps. They can only heat water to about 60 degrees. It's a good start. The problem I have is the support. I think as we get more and more into these sorts of systems, we're going to see better applications and more support in the rural areas. If we go into Melbourne, yes, we can see heaps of geothermal heat pumps, but that doesn't help a person down in Warrnambool or wherever you are. So, yes, great idea. I really want to get them, but I want to see the support come through first.
Yeah, fantastic. Thanks for that, Gabriel. And yeah, that is one of the issues with new technologies and emerging technologies is making sure our farmers have that support so that they can implement them. And if there is a breakdown, that they've got someone there to come in and fix the issues for them.